What if I asked for all of these elements and ions for you to rank them in terms of periodic trends to figure out which one has the largest radius, which one has the smallest radius, or alternatively, which one has the highest ionization energy? How would you do that? So the first thing I would do is I would figure out how many protons and how many electrons these all have. So in the periodic table, you can see that nitrogen starts with 7 protons and 7 electrons. So nitrogen 3 plus is going to have 7 protons and, oh wait, sorry, that should be nitrogen 3 minus. Forgive me on that one. So nitrogen 3 minus, if it starts with 7 electrons, 7 protons. Neutral nitrogen has 7 protons and 7 electrons, so a 3 minus ion would have to have 7 plus 3 electrons. If we look at the periodic table again, we see that oxygen has 8 protons and 8 electrons as a neutral element. So as a 2 minus ion, how many electrons does it have? 10, right. Fluoride ion, if you look at the periodic table and look for fluorine, you see that it has 9 electrons and 9 protons to start with. So how many does a fluoride ion have if neutral fluorine has 9? It has 10 total because you have to add one for the negative charge. Neon, just neutral neon, the noble gas, it has 10 protons, and since it doesn't have a charge, it's also 10 electrons. For sodium, that has 11 protons. If it was neutral, it would also have 11 electrons, but in this problem, I listed it as the +1 ion. So how many electrons does that one have? 10. I bet you're going to guess what the number of electrons the last one has. 10, right. Okay. And magnesium has 12 protons. Remember that the number of protons is defined by the element. If I say it's a nitrogen, that means that for sure the number of protons in the nucleus is 7. So that's definite. We can write that down. Whenever you see a nitrogen, that means 7 protons. Whenever you see 7 protons, that means nitrogen. One-for-one relationship there. Okay, so looking at that, we can ask the question, will electrons in these systems be more or less attracted to nuclei with this many protons? Are the number of electrons in each of these systems the same? They are. They're identical. Each of these systems has 10 electrons. So they're called an isoelectronic series. Isoelectronic means just the same number of electrons. So that's what isoelectronic series means. And the only difference between these systems, as far as these electrons are concerned, is how many protons there are, right? So a nucleus with 7 protons is going to be less interesting to them. It's going to be less attractive because each of these protons has a plus charge, right? So like 7 plus charges is less attractive to something with a minus charge than a nucleus with 8 plus charges. So here, on this end of the spectrum, we have more attraction between protons and these electrons, and on this end of the spectrum, we have less attraction. So if the electrons are being attracted to the nucleus more, will they be closer to the nucleus or further away? If so, to the right of this series, you have more of an attractive force between the higher positive charges in the nucleus and the same number of electrons. So that means that they are going to be more compelled to be closer to the nucleus. These are going to be smaller. Just think about the electrons being held more tightly, more attracted to that nucleus. And these are going to be larger. So in terms of atomic radius, the radii of the ions that are to the right are going to be smaller than the ones that are to the left. And the idea is that you can think about these systems as though you're just adding a proton. I know in real life you're not adding a proton, but when you're comparing them side by side, that's the only difference. There's some neutrons in there, but they don't count. So, like, going from this N3 minus all the way to this magnesium 2 plus, that's an extra 5 protons. So one of these electrons in these identical groups of just 10 electrons sees a much higher positive charge in the nucleus of magnesium 2 plus than it does in the nucleus of nitrogen 3 minus. So for that reason, those electrons are going to be closer to the magnesium 2 plus, much more positively charged nucleus, and then it's going to make for a smaller atomic radius. Okay, let's consider two ions, radium 2 plus versus francium 1 plus, and let's ask which one's bigger. So we have radium and francium, +1 for the francium and +2 for the radium. So I go to the periodic table and I see that francium has, neutral francium, has 87 protons and 87 electrons. So 87 protons for francium. And since it's a +1 ion, it's going to have 86 electrons. Whoops, 86. If I look at radium, radium has 88 protons, right? So how many electrons would a 2 plus radium ion have? 86. So these are, once again, isoelectronic systems. They have the same number of electrons. So the only difference, really, as far as this electron is concerned, because it's really, you know, the electron's not worried that much about mass. The electron is worried about charge, primarily. This electron sees a lot, sees like a nucleus with 87 protons. That's an 87 plus charge in this nucleus. Versus in radium, same electrons, but it sees 88 plus charges in the nucleus. So which one is going to be, which set of electrons is going to be more attracted to its nucleus? The ones that have 87 positive charges or 88 positive charges to see? Yeah, more positive charges, it's going to attract the electrons more. So this one's going to be smaller, and this one's going to be larger. So that's pretty straightforward, I think. Let's think about one more. What if we had francium versus francium 1 plus? So francium neutral would just have 87 protons, and since it's neutrally charged, it has to have the same number of electrons. I have to actually write it correctly, 87. And francium plus, since it's francium, has the same number of protons. But since it's plus charged, it has to have one less electron. Okay. So think about these electrons. If there's a ionic or atomic system that has 86 electrons and 86 protons versus one that has 87 protons and 87 electrons, which set of electrons here has a better view of the nucleus? The ones that have more rivals that get in the way, or the ones that have slightly less rivals that get in the way? These guys have one less other electron to compete with, getting closer to them and blocking the nucleus. So these are slightly less shielded than these electrons. So I would expect that the francium plus electrons are going to be more tightly held to the francium plus ion, and therefore this one's going to be smaller, and this one's going to be larger. So we can do quite a lot of damage with just the periodic trend that neutral elements get bigger as you go up and to the right of the periodic table, And we can also do a lot of damage in thinking about how different ions and atomic systems hold electrons closer together based on the idea that extra electrons will shield each other and will be less attracted to a nucleus, and that a nucleus with more positive charges will attract electrons more and make an atomic system or an ionic system smaller.